Hi everyone, welcome to lecture 3. We are discussing plate tectonics today, but before we get started, I'd like you to pause your video and answer these questions created from your responses to the lecture 1 activity. Take a minute to read this and complete it as a part of your lecture 3 activity. Here we have some avatars for your enjoyment. Today we'll discuss Chapter 2, The Way Earth Works, Plate Tectonics, in 3 parts. And this title slide picture on the left, there is somebody scuba diving between tectonic plates in Iceland. Iceland is the only country known to straddle 2 different tectonic plates, a tectonic plate boundary, and also a hotspot, and we'll discuss more of that later today. First off, we want to discuss something called continental drift. This was a hypothesis proposed by German meteorologist and explorer Alfred Wegener in 1915, and he proposed that the continents are in motion and were once assembled into a single supercontinent that he called Pangaea. So on the left side of your screen, you have a picture of the Pangaea fit, where you've got South America, Africa, North America, and Europe all fitting together to some degree into one continent. So Wegener's evidence included this fit of the continents that seemed to go together like puzzle pieces very well. He also had evidence of the distribution of climate belts between continents, distribution of fossils, and matching geologic units, and we'll discuss each of these. We won't have time in the video, but I encourage you to go to YouTube and watch this video by Christopher Scotese on plate tectonics, paleogeography, and ice ages. This goes over the past 500 million years, I believe, and shows you the formation and breakup of the Pangaea supercontinent. That was the video, which we are skipping. So, Wegener's evidence. First off, we want to talk about distribution of climate belts. So Wegener aligned similar ancient climate belts between continents, and these climate belts basically are glaciated, desert, and tropical. So you can see that in the figure on your left. And what I would like to ask you is to think about if there's a spatial relationship or geographic pattern to these climate belts, and if so, why do you think this is the case? Why do you think certain climate belts existed in certain places, for example? And finally, what rock types are associated with each climate belt and why? This would be something to include in your notes. We also have the distribution of fossils across continents. So Wegener found that there were many fossils common to 2 or more continents that are now separated. This suggests that the continents were connected in the past. So on the left-hand side of our screen, we've got different fossils. We've got Mesosaurus, Glossopteris, Lystrosaurus, and Cynoganthus are just some examples of fossils distributed across different continents. And so what I would ask to you is, why do you think Glossopteris was more well distributed than other species? As you can see from the figure, Glossopteris was present on all of the continents shown. And finally, Wegener's last piece of evidence was matching geologic units between continents. So distinct rock types have been found in now widely separated regions, and when Wegener put the puzzle pieces of the continents back together, particularly South America and Africa, and North America, Africa, and Europe, he found that there were similar types of rocks, mountain chains, that all lined up in a specific pattern. So for example, the Appalachian Mountains and the Caledonides in Great Britain, Scandinavia, and the Atlas Mountains in Africa all tend to line up, indicating they may have been part of one chain in the past. And then rock types in South America and Northwest and Africa match up as well. So the purple portions of South America and Africa are Archean crust. They are very old crust and they are cratonic crusts. And then in between them, we have these Proterozoic mountain belts, which would have sutured these cratons together.